Hi, this is Rohan from educator.ai. Let's dive in. Welcome. In this video we build Evals, the tests that measure whether your LLM feature actually works. By the end you'll be able to review a pull request and tell if the quality is real or just vibes. Here's the trap every LLM developer falls into. You change a prompt to fix one bad answer, ship it, and feel good. But that same edit silently breaks 10 other cases you never rechecked. Without measurement, your users become your test suite, and that's expensive. The rule is simple: you cannot improve what you do not measure. In normal code, you assert that a function returns exactly 5. But LLM output is fuzzy. Many different answers can be correct. So instead of one true answer, we build a repeatable score, and we watch that score move. Think of evals as a unit test suite, but for judgment instead of exact values. Just as you run tests before merging code, an eval runs your prompt over a saved set of cases and reports a pass rate. Green means ship. A sudden drop means you just broke something before your users do. Step 1 is the dataset. Collect real inputs your feature will see: questions, tickets, documents. For each one, write down not the exact answer, but the properties a good answer must have. Here, the reply must mention the refund policy and must not invent order details. A dataset is never finished. Start with happy paths, add edge cases like empty or enormous inputs, and add adversarial cases like prompt injection attempts trying to override your instructions. Crucially, every bug a user reports becomes a new raw, so the same failure can never sneak back in. Step 2. Scoring. Reach for the cheapest tool first. Exact, deterministic checks. Does the output pass as valid JSON? Does the chosen category belong to your allowed set? Does a required substring appear? These cost nothing, never flake, and catch a surprising number of real bugs. When answers are open-ended, escalate. A rubric checks measurable properties. Is it under the length limit? Does it cite a source? And when even that isn't enough, an LLM-judge grades the answer against written criteria. The judge is powerful, but fallible, so use it last, not first. The LLM-judge deserves care. You hand it the grading criteria, the input, and the answer, and ask for a structured verdict, pass or fail, plus a short reason. Never let it reply in free prose you then eyeball. Force a machine-readable field so the score is deterministic to pass, even if the judgment isn't. Now, the whole pipeline. Load the dataset, run every input through the prompt and model, score each output, and aggregate into a single pass rate plus the list of failures. The steps from run through score must happen together on the same fixed dataset. Otherwise, your numbers aren't comparable across runs. This is where evals earn their keep. On every pull request, the suite runs on a frozen dataset and compares the pass rate to the baseline. If quality dropped, the build fails and the merge is blocked. That boxed region runs automatically. Evals catch regressions before your users ever see them. Here's a real scorer. 3 model outputs, each expected to classify as refund. We parse the JSON, check the category is in our allowed set, and compare to what we wanted. One passes, one has the wrong category, one isn't even valid JSON. The result? A concrete pass rate of 0.33. No vibes, a number. For open-ended answers, here's a judge that grades grounding. Does the answer stick to the provided sources and admit ignorance when they're silent? Note temperature 0. We want the judge's verdicts as stable as possible, so rerunning gives the same score. And it returns structured JSON, not prose, so we can aggregate it automatically. A few traps to flag in review. A judge run at high temperature gives wobbly scores you can't compare. A dataset of 5 cases means one flaky answer swings your whole rate. And if you tune the prompt on the exact same cases you measure, you are overfitting. Your eval says 99%, while production quietly fails. Use this as your review lens. Approve when there's a frozen dataset with expected properties, exact checks before judges, a judge pinned at temperature 0 returning structured output, and a CI gate that blocks on regressions. Request changes when there's no dataset, the judge grades loose prose, injection cases are missing, or a fixed bug never became a permanent test case. So 4 things to remember. Measure before you optimize, replace vibes with a repeatable score. Build a dataset of inputs paired with expected properties, and grow it with every bug. Score cheaply first, escalating to a judge only when needed. And wire it into CI so regressions get caught in the pull request, never by your users.